In this presentation, what we're going to do is we're going to look at some extra examples on how to solve rational equations using the LCM strategy. So with that, we have two problems here, and what we're going to see is that we're going to use the LCM strategy because we have multiple rational expressions or multiple fractions on one side of the equation. And in doing that, we can see our procedure over here that step number one, we want to be able to identify what the LCM is equal to. And a lot of time in these problems, it's nice for us because a lot of times we have hints to what the factored form is already given to us in our denominators. So I understand that x squared minus 9 factors into x plus 3 and x minus 3. So there's our LCM. Check off step number one, done. Step number two, realize all fractions get multiplied by the LCM. So I'm going to take x plus 3 times x minus 3, and each one of these fractions gets multiplied by the LCM. So that's how I write my work. You might write yours a little bit differently. But the key here is that we realize that this x minus 3 will reduce with that one. This x plus 3 will reduce with that. And then both of these will reduce with the x squared minus 9. This is a nice step for us because now, as it states over here, we are going to be left with no fractions. That's our look for. So once I'm done, I see I have 4 times x plus 3. I'll have 2 times x minus 3. And on the right side, everything reduced, so I'm just left with the numerator, 2x plus 2. So here's my look for, and it's an equation that there's no fractions in it, so it's no longer a rational equation. It's just a simple linear equation for us to solve. In solving this, I'm going to just go through my procedure of distributing. I'm going to combine like terms, so 4x and 2x gives me 6x, 12 and negative 6 gives me plus 6. I'm going to bring my x's to the left to get a 4x, constants to the right to get negative 4, x equals negative 1. Last step, it says solve, and then check for extraneous solutions. So I want to make sure this value of negative 1 doesn't give me a 0 in any of my denominators. Since negative 1 gives me an actual value, not a 0, it checks off. That is my solution to the first example. Let's take a look at a slightly different example. All right, similar process. We see two fractions on one side equal to 1, but this time we have to be careful. We have a subtraction symbol, which just gives us a little bit of an alert that we have to make sure we're distributing correctly. We're still going to start off by finding the LCM. And again, we see that we have the difference of squares pattern. This time we had a leading coefficient not equal to 1, but not a big problem. So now I'm going to multiply everything by my LCM. A lot of students catch on that you end up just multiplying by what's missing from the common multiple, but I like showing this step so you can visually see what's happening. 2x minus 1 and 2x minus 1 reduce. 2x plus 1 and 2x plus 1 reduce. And then again, everything reduces here. So now what's my statement? X times 2x plus 1 minus 2 times 2x minus 1, and then simply an x squared plus 20. Now from here, again, I'm just going to simplify and solve, but I like my look for because right now there's no more fractions involved. I just have a quadratic. So I'm just going to go ahead and kind of clean this up and simplify the left side and get 2x squared plus x minus 4x plus 2. There's the catch right there. Make sure you distribute. Negative and negative gives us plus. Again, I'm going to try to get everything over on the left side. So that means I'm going to subtract an x squared, which leaves me with x squared. X and negative 4x give me negative 3x. Plus 2, and this is going to be a minus 20, is negative 18. This really makes me happy because now I see that this will actually factor into x plus 6, x minus 3. Nope, I lied. Ooh, that was close. I needed x minus 6 and then an x plus 3. And again, the reason I need that is because my middle term is negative, so that's why I knew the 6 had to be the negative. That was a close one. That's going to then tell me x equals 6 or negative 3. Again, I'm going to go ahead and check to make sure it doesn't result in a 0 in the denominator, and it doesn't look like neither the 6 nor the negative 3 will give me a 0, so both of those solutions work out. In summary, all right, make sure that we start off by showing that we identify what the LCM is actually equal to. We're going to multiply by the LCM, and upon multiplying by the LCM, I get an equation that I could just use some of my quadratic solving strategies or linear solving strategies to get the final answer. Be sure to check for extraneous solutions.